How long will your test be? The thing is, you have to be able to take it in one class period. You have to be able to take it in 2 hours. So usually for the final, I let you take the test from 6 to 8. So then I'll give you until maybe 8:10 to get it submitted. But I mean, some students are done much sooner, kind of depends. And in some ways, I feel like the final is not that bad, even though it's cumulative and it covers everything that you've talked about in class. The nice thing is, as long as you've done your final exam review, the material should still be kind of fresh. You do the review, you've seen this stuff before, and then it's not like a big shock to your system when you see it again on the final exam. But it has to be short enough so that you can reasonably take it and finish it during class time. So, I mean, it might be slightly longer than normal test, but it can't be much longer at all. Sometimes I just space it out differently. But yeah, it really can't be much longer than a normal test. Any other general questions about the final? By the way, I don't know when grades are due. If it's Monday, let me look real quick. Usually I get an email. I don't remember seeing one come through. Oh, they finally did send me the video for the final review session. So I can send you that also if anyone's interested in watching that. That came through a couple hours ago. If you were not able to make the final review session. Okay, so let me see, I'll send you that. You know, if I send you this link, I can even put it in the chat and you guys can check and just verify that it works. Let's go to the end, don't do that. Or the passcode's not correct. Sent Dave the email. I don't know. All right, I'm going to copy the link and then I'll give you the passcode. Let's see. The passcode is, and you guys can check it and see if it worked for you. Try that. So that's a link to the math department's final exam review session. Yeah, see, when I entered it, it said wrong passcode. Don't know. Don't know. Passcode's not correct. Copy that. I don't know. Some people are saying they finally got it to work after several tries. I don't know why you'd have to try several times. Okay. Now I got it to work. Okay, so there's that too, if you wanted to go through that. I don't know exactly what she covered in that review session. Okay, yeah, I don't know why it took a couple tries. Yeah, I did get it to work. I think there might be, when I copied it, I know there was like a space at the end, and I don't know if Zoom counts spaces in the passcode. I have no idea, but I got it to work. So if you want to watch that, that's on there. I don't know. I doubt she got through the whole sheet. I really doubt that, but feel free to check it out and see. Oh, good. I can start to see some faces now. Any other general questions about your final? Process questions. Oh yeah, I don't have an email about when grades are due. Usually they're due the following Monday at like 4 p.m. So that your grades should, I'm guessing, will be due a week from today at like 4 p.m. And usually as soon as I post it, students can see it. But before I officially post it, I'll have your grade in D2L. So if you don't have any general process questions, let me know if you have questions on the review sheet or on any of your previous tests or on anything mathematical. I'll give you a minute to figure out what you wanted to ask me. And I did put in the email some stuff that you could skip. Stuff from chapter 8, mostly. And then there were 2 topics that we skipped in chapter 3 that you won't have to worry about. Does anyone have questions? Or did you just want me to randomly pick stuff? Number 7. I don't remember what section of the notes that was from. Let's see. Number 7. 3.5. Number 7 was from 3.5. Mm-hmm. Number 7 was finding the domain, asymptotes, intercepts, and drawing the graph of a rational function. Okay. Because if I tried to go through this whole review sheet with you tonight, I would never have the time to finish it. I can pick at random. Oh boy. All right. I should have made myself another blank one of these, but it was 26 pages, this spaced out thing. It took forever to just print that out. Took me forever to scan it, but luckily I have that wonderful scanning app. Okay. Oh, by the way, with your scanning app, guys, there were 2 tests that were submitted where they were so blurry, I could barely even read them. And then some of them are scanned so that you can see the page at this weird angle and you have so much background in them. With the scanning app, if you hold the phone or whatever, your iPad or whatever you're using to scan with over the paper and you hold it there, it will actually start to create a rectangle for you. And it'll make a really nice, beautiful scan. I don't know if you're taking pictures of it and scanning it that way. Play around with that scanning app, because when I scanned in this review sheet for you, I scanned in the whole thing on Genius Scan. Okay, numbers 15 and 16 Mia has requested. That's always helpful. Okay. That's good because we forget how to do these. Let's see if I can focus this a little better. No, it doesn't have anything to focus. I think that's what it's confused about. Okay, let me give it something to work with here. Okay. This is number 15. So you're being asked to find all possible rational roots for the function. Remember that when you're looking for those rational roots, you're looking for factors of P over factors of Q. So this guy would be P, and then this one would be Q. So factors of P, list all of them. So I know that, for instance, I can multiply 1 and 6 to get to 6, or I can multiply 2 and 3. So I'm going to go with plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then I'm going to divide that by the factors of Q. In order to get to 2, I can only multiply 1 and 2. So I'll use plus or minus 1 and plus or minus 2. And then in order to get the possible rational zeros for this function, I'm going to just take the quotient and I'm going to, what I like to do is I take every value in the numerator with the first value in the denominator, and then I go over and use the second value of the denominator. So we can say that the possible rational zeros are, first I'm going to start with the denominator of 1. So 1 over 1 is 1. 2 over 1 is 2. 3 over 1 is 3. 6 over 1 is 6. And then I'm going to move on to the second value in the denominator, which is 2. Now, some of these values are going to repeat. So 1 over 2 gives me a half. I don't have that yet. But 2 over 2 simplifies to 1. And I already have that down, so I don't need to write that. 3 over 2 I don't have, so we'll include that in the list. And then the last one would be 6 over 2, which simplifies to 3. I already have that one down here, so I don't need to write it again. So this is the list of possible rational zeros. And for number 15, that was actually all you were being asked to find there. Does anyone have questions on 15 or how to find possible rational zeros? I want to remind you also that that does not mean that all of these values will be zeros. That just means that if you have rational zeros, and you might not have any rational zeros, they might all be imaginary. But if you do have rational zeros, they're going to have to come from this list. They can't come from anywhere else. So number 16, we're working with the same function, but this time we're being asked to find all rational zeros. Okay, I'm going to get my, I can't remember. I think when it's dark, my calculator does not work properly in this light. This is not terrible though. The thing is, it's just a pain to move back and forth between the emulator because then I have to stop sharing my notes. Okay, we'll do the best we can. All right, so let's, we're going to graph our function. 2x cubed plus 3x squared minus 11x minus 6. Two x cubed plus 3x squared minus 11x minus 6. And what you're going to do is you're going to figure out which one of these rational zeros is actually on the graph of your function. And you're going to do that by looking at the graph of the function. Oh, not the table, the graph. I'm in a weird Zoom here, which is probably not going to be very helpful. So I'm going to go back to Zoom standard. And you're going to look at the graph. And you're going to figure out which one of these values from your list actually looks like a 0 on the function. So for me, it looks like -3 and 2. And remember, you can always verify that by going to the table. So if I want to use the value 2, usually it's easier to use a positive value than a negative one when you're using synthetic division. I'm just going to go to the table and verify that 2 is actually a 0. So I'm going to enter the value of 2 if you're on ask. We were probably set to ask. If you were set to auto, then you're just going to have to scroll over to 2. But when I let x be 2, y is 0. So that's how I know that 2 is a 0 of the function. So we're going to start out by using our calculator to pick a 0, and then we'll use synthetic division with that 0 to determine the rest of the zeros of the function. So use your calculator to choose a rational 0. And then we're going to verify using synthetic division. All right, so I'm going to choose the 0 of 2 that we found on the graph. And then I'm going to write the coefficients from the function in my synthetic division. So my coefficients are 2, 3, -11, and -6. And we're going to pull down the 2, and then we'll multiply and add. So 2 times 2 gives you 4. 3 plus 4 is 7. 2 times 7 is 14. -11 plus 14 is 3. 2 times 3 is 6. -6 plus 6 is 0. Now, remember that when you pick a value that's actually a factor, or when it's actually a 0, I should say, of your function, you're going to get a 0 remainder. That's good. That means that x minus 2 is a factor of f of x. So I chose 2 because when I looked at the graph of the function, I can see that the graph crosses the x-axis at 2. So you're looking at this cubic function. I chose 2 just because it was a positive value and it was clearly easy to see. You can also see that your graph crosses the x-axis at -3, and it looks like probably -0.5, but it's kind of hard to say when it's in between those two numbers. So that's why I chose 2. I'm looking for a value that actually is 0, meaning that the graph of the function actually crosses the x-axis at that 0.
Can you go over what you did to get like the 4, 14, and 6 again?
4, 14. Oh, yeah. So, all right. So the first number gets pulled down, and then you multiply. So you're always multiplying by the number in the box and whatever number is down here, depending on what column you're on. So 2 times 2 gives you 4. 3 plus 4 is 7. And then you'll repeat the process over again. So 2 times 7 is 14. -11 plus 14 is 3. 2 times 3 is 6. And -6 plus 6 is 0. Any other questions before we continue? Okay. So what we're going to do now is we're going to take these coefficients out of this bottom row of your synthetic division. So right now we've shown that x minus 2 is a factor of your function. So you don't have to include this step, but really what we've just shown is that we have this depressed polynomial. Remember, if this is your remainder, then you have constant. You have a linear term, and you have a quadratic term. So what you have left over is 2x squared plus 7x plus 3. And since you found that 2 was a 0 for the function, what you really found was that x minus 2 was a factor. So what we're doing here is we're just kind of reducing this polynomial down by writing it as a product of factors. So you started out with this third degree polynomial. When you divided it by 2, you were really dividing your polynomial by x minus 2. Now, really, you could have also used long division here. You could have taken your original function, divided it by x minus 2, and again, you would have seen the same factor of 2x squared plus 7x plus 3. Synthetic division's easier to work with, but really, this is what we've just shown, that we can take our original f of x and rewrite it as the product of these two factors. But if you don't write this down, no big deal. You don't have to write it down. All you need to do is work with your remaining polynomial. Now, when I did this one on the review sheet on the key, I showed this part of it 2x squared plus 7x plus 3 using the quadratic formula. So what you're doing here is you're taking your depressed polynomial and you're trying to use that to find the remaining zeros. And since you had a third degree polynomial, you know you're going to have 3 zeros. Now, it's possible some of them could repeat, but I don't think you'll see that happen here. But what you're trying to do now is get 2 more zeros out of this. You found one of them. X equals 2 is a 0. You're trying to find the other 2. Okay. I'm going to do that next. Any questions? Okay. Now, I'm going to show this by factoring. I showed it on the key that I gave you by using the quadratic formula. But this one you can solve by factoring. 2 times 3 is 6. And the 2 numbers that multiply to 6 and add to 7 are 1 and 6, both positive. So you can rewrite this by rewriting the middle term as 2 terms with these 2 coefficients. So you can rewrite it as 2x squared plus, and you decide what order you like, 1 and 6. So you've turned 7x into 1x plus 6x. And this is the method of using factor by grouping to solve a quadratic equation. Now, this won't always work. Sometimes you have to use the quadratic formula. You'll know you have to use the quadratic formula if you can't find numbers that add to the middle term. So sometimes you'll multiply 2 times 3, you'll get 6, and you won't, maybe you'll have a different middle term like 2, and you can't find any numbers that add to that number, and you have to use the quadratic formula. All right, so now you'll factor by grouping. You'll group the first 2 terms and the second 2 terms, or group in any order you like. Take out your GCF. In the first set, your GCF is X. In the second set, it's 3. See what you've got left. And now you have 2 terms. There's so much screaming down there. Sorry, it's really like I have a hard time concentrating. My 1-year-old is almost 2, and that's her new thing. Like, she gets mad about something and just screams, like as though that's going to change anything. I'm just like, why are you screaming? You're not just going to get what you want. But it's like blood curdling. Anyway, now you have 2 terms, and you have a common factor in each term of 2x plus 1. So take out the 2x plus 1, and that leaves you with x plus 3. All right, now you're just going to use the 0 factor property to solve these 2 equations. And yes, indeed, that 0 that we saw was actually -0.5. And you could have verified that in your table on your graphing calculator. But remember, the whole point of this is not to look at your graphing calculator and say, oh, the zeros are -1/2 and -3 and 2. Done. Your job is to use synthetic division to find these zeros. That is what you are supposed to be doing. Any other questions on 15 and 16? If not, prepare yourself for some other exercises that we can do. If you had any picked out, let me know. Otherwise, I'll find something. 53. Was 53 one of the ones I said not to do? Let's see. I don't know why that sticks out to me. Maybe it's not. Oh yeah, 53 you can skip. That's a 3.7 problem, Michael. So don't worry about that one. That's a variation. Normally I do cover it. It's not usually something that gets skipped, but we spent a little extra time on those zeros. 39. Yeah, so 39 was given to you as solved by writing in reduced row echelon form. On your test when you did this, I actually didn't force you to use this. Now, technically, you had to do this when you found the inverse by hand, but when I asked you to solve a system of equations using matrices, if I asked you to use row echelon form, I didn't ask you to actually go for reduced row echelon form. And the spacing for this was not very good for this particular problem, but I'll go over it. I started it up here. And if you want, I can finish it the whole way, or I can use the back substitution method. So remember that row echelon form, let me see where we actually had row echelon form. Here. So row echelon form, remember, is when you have the zeros in that lower corner of your matrix, and then usually we say you have ones along the diagonal officially to be in row echelon form. But if you're just using back substitution, then it's not a big deal. So most of the time when we did these for solving systems of equations using matrices in row echelon form, I would have you get to this point and then you would use back substitution. Now I put the full solution of reduced row echelon form on here. But what I'll do now is go through this one more time and just use the method of back substitution, which is mostly what we focused on when we were doing this. Yeah, I mean, so yes, you have seen the method using reduced row echelon form, but our main focus was using back substitution. No, so in the final, you don't need to do reduced, no. So I almost didn't do this one. It said reduced, and I was almost like, let's just say row echelon form. But then I just put it on there anyway, so it wouldn't cause confusion. But we'll do it again, and we'll use back substitution. Let's see, I'll say using REF and back substitution. All right, so our system was x plus 5y minus z equals 2, 2x plus y plus z equals 7, x minus y plus 2z equals 11. Okay. So let's go ahead and put this system into an augmented matrix. Wonderful. You can put the line in, don't put the line in. It doesn't matter. We're just going to be running through these matrix operations. Okay, so our goal is that we want to take these three values right here and make them 0. That's going to get us to row echelon form. Now remember that row echelon form is not unique. That means that your row echelon form could look different from someone else's, and that doesn't mean that your matrix is incorrect. So keep in mind that your matrix might look different, and that's okay. Also, my math lab, if you're looking through the solutions there, they might give you an REF matrix and yours might look different from theirs. Doesn't mean yours is wrong. You can put it into your calculator and put in row echelon form and get a different matrix. Just be aware of that. Reduced row echelon form, however, has one unique solution. Okay, so we're going to start out by making this 2 a 0. In order to do that, I'm going to take -2 row 1, and I'm going to add that to row 2. So I'm going to make this guy a -2, and I'm going to add that to the second row, and we're going to get a 0 there. And then we're going to see what else changes in the process. So -2 row 1. Make sure that all of your signs are correct. Right, Karen. You don't have to start with the left column first. It's up to you. If you want to work on this value first, that's totally fine. And then if you're doing reduced row echelon form, you can even start with one of these values. Okay. Now, technically, I'm not going to be able to turn this into a 1 without making these fractions. And I don't want to make them fractions right now because anytime I manipulate the row, that's going to make my life harder. So what I'm going to do now is just reduce the values a little bit to make them slightly smaller. And I'm going to divide by -3. So -9 divided by -3 is +3. And then switch the signs on those two and get -1s. Now I'll put this back in for my new row 2. So row 1 is unchanged. Here's my new row 2. And there's row 3. Any questions so far? Wonderful. All right, now let's worry about this one. We'll make this a 0. So our third row, first column. Now, I think it's pretty straightforward here that you can notice that these two are both 1s. So I'm going to take negative row 1 and add that to row 3. So going back to our old notation here, negative R1 plus R3 is going to be our new row 3. So -1, -5, +1, -2. Add that to row 3. And remember, if you liked, you could have taken row 1 minus row 3. I just like to do plus because I don't want to forget to distribute the minus sign. And again, I'm not going to be able to make this a 1 without making this value a fraction, but I just want to reduce the values and make the first number positive. So I'm going to go through and divide by -3 again to just get some smaller numbers. So -6 divided by -3 is +2. Then I'll get -1 and -3. And that'll be my new row 3. Now we're very close to having row echelon form. Does anyone have questions so far? So my next move will be to make this 2 a 0. Because remember, I need to have this lower corner be all zeros. Now, don't go back and use row 1 because you don't want to reintroduce a non-zero value for the first column. You're going to use row 2 and row 3. The thing is, if you want to combine those two rows to make this guy a 0, then you're going to want to pick a value that's common to both of these. So I want to have a 6 and a -6. It's up to you how you get that. But I would say let's take -2, row 2, and we'll add that to 3, row 3. And if you wanted to do that differently, fine. I mean, some of you might have reduced this down using fractions and you would have already had a 1 here. I mean, there are an infinite number of possibilities. So -2, row 2. And 3, row 3. And I want these values to be positive, not negative. So you can think about it as multiplying or dividing, whichever you like better, by -1. And that will give you your REF matrix. Well, actually, technically, we have one more small thing to do to officially be in REF form, but I don't even think we're going to do it because I like to keep all of these coefficients integers if I can. Okay, so officially, REF form has only ones on the main diagonal. You have a 3 here in the second column on your main diagonal. However, in order to make this value a 1, these two values would have to be 1/3 or -1/3. Officially, to be in REF, that's what you need, but we're just going to use back substitute to solve. So in order to do that, we're already set up for that. So if you don't make this value a 1, it's not the end of the world. Whatever makes this easier for you to go back through and back substitute and solve. Now remember, you could turn this into a system of equations by putting this back together again using those original variables. So we're going to have x plus 5y minus z equals 2. And then you'll have 3y minus z equals -1. And then z equals 7. Okay, so we already have z equals 7. That's an important piece of the puzzle. We're going to use the value z equals 7 to find y. So we're going to go to this equation. Don't go to the top equation because you don't have y or x. You just have z. But we do have our z here. So we know that 3y minus, well, if z is 7, then 3y minus 7 equals -1. So we're substituting in this value for z. And then you'll solve for y. So add 7 to both sides. -1 plus 7 is 6. And you'll get y equals 2. Box it up so you can find it. And then you're going to go back to your first equation. Before I continue, does anybody have a question here about the back substitution? So we'll go to the first equation. We're going to solve for x this time. So plug in anything that's not an x. So we have 5y, so that's 5 times 2 minus 7 equals 2. And then we'll simplify and solve. You'll get x equals -1. So your ordered triple here is -127. Now remember, you would have gotten this answer if you would have put this matrix into your calculator and used our REF, then you would have gotten only ones on the main diagonal, and you would have gotten something that looked like this. So what I actually found on your review sheet was the reduced row echelon form. So that means that when you get to the place where we were, which was right here, that's where I kept going here on your review sheet. So I started here at the top and went through. I made this guy a 0, then I made this one a 0, and then I made that one a 0. And then I went further to make the top corners all zeros. So to do that, I started out here in the second column, I made this value a 0. Then I worked my way through, I made this value a 0. And then I last made this value a 0. And then I went through and made sure that all of the values on the main diagonal were 1s. The nice thing about reduced row echelon form is that this answer is unique, and you have z equals 7, y equals 2, x equals -1, as long as you have 1s on your main diagonal. So that's the nice thing about RREF, but if you would like to use REF with back substitution, that's fine too. That's probably a little bit easier, but I mean, if you're really good with your row operations, just because, I mean, it's really just performing more row operations, then keep going with that. But I do think back substitution is a little bit easier because you get those 3 zeros and then you kind of revert back to something that maybe you're a little more comfortable with at that point. But same answer, slightly different process. Any questions on number 39? Okay. Does anyone else have a problem they wanted to go over from the review sheet? $46. Okay. $46 was a skip. So you were supposed to skip 43 through 51. 43 through 51, and then also skip 53. 55. The half-life. Here is 55. The half-life of aspirin in your bloodstream is 12 hours. How long will it take for the aspirin to decay to 70% of the original dosage? Now remember that half-life means that you're decaying to half of the original dosage. You already know the half-life. So if you're trying to decay to 70% of the original dosage, you're expecting it to be less than 12 hours. But go ahead and use your formula here. You have your final value is equal to your initial value times e to the kt, which I put on there for you. Now, the way that we use the formula for half-life, your final value is going to be half of the original value. So for half-life, we get rid of these two values and we say that 1/2 equals e to the kt. And that's because your final value is always half of the original. So if you want to think about this value as being a half and your original as being 1, that's where this comes from. No matter what your original value is, your final value will always be half of that. So this is your half-life formula. Oh, Ben, sorry, you asked about all the skips. I put them on the top here, but I don't know if it was before or after I scanned. Well, it's close. You were supposed to skip 13, 43 to 51, and 53. Are you going to have a lot of word problems on the test? I mean, not like a lot, but definitely word problems, yeah. 52 next. Yes, I will try to remember to go back to 52. Or were we supposed to skip it? I don't remember. It's gone now. 52 wasn't a skip, was it? No. Okay. Okay. Let's see. we have our half-life formula. We know information about the half-life. We know that the half-life is 12 hours. So you can plug that in for T. Now, remember, if you're talking about T in hours, then you need to be consistent with that. So whatever answer you get for T is going to be in hours now, because K is going to be based off of a T that's been given in hours. All right, so we're going to solve for K here. Once we find K, we're going to go back and write our equation again to solve for the value of T required for our value of K whenever our final dosage is 70% of the original. Or I should say when our dosage has decayed to 70% of the original. Okay, now I'm trying to get K out of the exponent. Remember, when your variable's in the exponent, you need to use a logarithm to get it out. So we're going to take a log on both sides. We also know that the natural log of E will just bring your exponent down. So the natural log of e to the 12k is just 12k. Now, sometimes you'll be going through your My Math Lab homework. I'm assuming this happens, and you'll see something like you'll see that they've rewritten the log of 1/2, because remember that you can rewrite this using subtraction. So this is really the natural log of 1 minus the natural log of 2. So if you see something like this happen where you had log of 1/2 and then it disappears and becomes something else, well, the reason they do that is because a lot of times it's cumbersome to write the natural log of a fraction. The natural log of 0 is, or I'm sorry, the natural log of 1 is, if you don't remember, think about your graph of your natural log function. Or you could always put it into your calculator if you're not sure, but I'm here to tell you right now that the natural log of 1 is 0. So sometimes when you see natural log of 1/2, you're going to see it instead as negative natural log 2. And you can kind of see how this works too, because then you can always move that negative back up, and then you have the natural log of 2 to the negative first power, which is really just the natural log of 1/2. So another way of thinking about this. So if you want to use negative natural log 2 instead of natural log of 1/2, that's fine. If you were thinking, well, I was never going to do that to begin with, that's fine too. I mostly just wanted you to be aware of it in case you see something like that happen on My Math Lab in one of your solution processes, or you're looking online somewhere trying to study and you see something weird happen with your log of a fraction. So that's up to you if you want to rewrite that. I'll leave it because I think you'll leave it. I just want you to be aware. Okay, so we have natural log 1/2 is equal to 12k. And then k is equal to natural log 1/2 divided by 12. Now this is an important result, so I'm going to put a box around it. It's not our final answer, but we are going to need that value. This was just a note here. Okay, so now we're going to use the value that we found for k, which is that decay factor, and we're going to use it to determine how long it's going to take our aspirin to decay to 70% of the original dosage, not 1/2, but 70%. So to do that, instead of using a 1/2 formula, I'm going to use a 70%. And then, again, we'll use our e to the kt. Now, if you're wondering, well, like, why isn't she going back up to here again? Because it doesn't matter what the amounts are. All you know is that the final amount is 70% of the original. And you weren't even given any information about the amounts. That's all you know. So if this gives you half-life, think about this as being 70% life. Okay, now use your value for k. And be careful when you enter this. I saw on the, I think it was on the answer guide that you guys were given. I don't remember though where I saw this. It might have been in there were like two versions of this, and one of them was old, and I didn't realize it till I went through here last night. But when they had found K, they used a truncated decimal, and then their answer was off by, I don't know, like 100th of a percent or something, which is not the end of the world, but you know how I like to leave everything completely exact. So I'm going to use my value here for K exactly as it is. So ln 1/2 divided by 12 times t. And the question I'm trying to answer here is how long to decay to 70%. Okay, so we're using our value of K in this new equation. Questions so far? All right, so now again, we're trying to solve for a variable that's inside the exponent. So we're going to do the same thing here. We're going to use a natural log to pull that variable out of the exponent. You don't even need to carry around that extra 0 if you want. Just whatever makes you feel comfortable here. We're taking the natural log of e to the ln 1/2 over 12 times t. And then that really leaves you with the natural log, or no, we can get rid of our natural log in the bottom. We just have this one at the top. So the natural log of e, kind of you can think about it as canceling each other out, and you bring that exponent down. And then to solve for t, we're going to divide both sides by this coefficient. So we're going to say that t is the natural log of 0.7 divided by the natural log of 1/2 divided by 12. And if you want, just for ease, putting this into your calculator, feel free to put parentheses around it just to make sure that you enter it correctly. Okay, let's see. So we have ln 0.7 divided by, in parentheses, ln 1/2 divided by 12. So notice my entire denominator is in parentheses. When I closed off that natural log in the denominator, I made sure to close off right after the 5. Divided by 12, and you have one more parenthesis. And when you do this, you get approximately 6.174878074. Does anyone have a question about how to enter this into their calculators? And remember that t was measured in hours, and we talked about t being 12 hours earlier. So whatever we get now for t has to use that same unit. So we could say that t is approximately 6.2 hours. Any questions on that one? I think I need to have my husband like winterize this window. I just sit here and freeze. And when I get downstairs after class ends, like I just don't ever get warm for like the whole rest of the night. It's terrible. Why is it so cold? Okay, so number 52. I find this problem to be a little bit weird because a lot of times when you're given a function for a problem like this where a ball is being thrown, usually you're given h of t, where t is the time that the ball has been in the air. So this is a little bit different. It's not the end of the world because I guess it makes you think a little bit more. But I remember finding it weird as I went through and filled out the solutions for you. A ball is thrown upward and outward from a height of 6 feet. The height of the ball, h of x, in feet is given by h of x equals negative 0.8x squared plus 3.2x plus 6. Now, remember, you were told that the ball was thrown upward from a height of 6 feet. Well, that's what this represents. This is your starting height. So you don't actually have to use that information because it's given to you in this position function. So this is the height of the ball. That's the height of your ball in feet, where x is the ball's horizontal distance from where it was thrown. So if you're thinking about x being 0, that means that the ball hasn't moved anywhere horizontally. Well, if x is 0, then the height of the ball is 6 because these two terms would zero out. So if you want to try to kind of reconcile that in your mind, that's what that means. What is the maximum height of the ball and how far from where it was thrown does it reach this height? So if you're thinking about this quadratic function, and if you want to even graph it, I think that couldn't hurt. If you go to your y equals and you just pop in your function negative 0.8x squared plus 3.2x plus 6, you can get an idea about what's happening to the ball, and you can even check this in your calculator. I mean, obviously you'll have to show me your work on your exam, but this is something where you could check the value for the height, that y coordinate of the vertex, by using that calculate function in your calculator. But this function is modeling the behavior of the ball. So here's that 6 feet where it starts out. It's thrown from this height of 6 feet, goes up, it achieves a maximum height. The function, remember, will tell you your maximum height, and then it goes downward. The x coordinates here are telling you how far it is away from the starting point. We're going to go back to the calculator in a minute because I want to remind you of how to use your calculator to verify that your answer is correct. But remember, you will have to show me your work. Okay. So really for the max height and how far it is when it reaches the max height, we're looking for the vertex. All right, so to find the vertex, remember the x coordinate of the vertex is negative b over 2a. This is probably the fastest way to find the vertex. The other thing that we did for finding the vertex was we put the original function in vertex form, which was a times x minus h quantity squared plus k. I think that'll be a lot harder in this case. You can do that, but most students I know don't complete the square unless they feel like they have no other choice. So I'll leave that up to you. All right, so negative b is negative 3.2 and then over 2a. And then we'll simplify. 2 times 0.8 is 1.6. Oh my gosh, that scream is just, yowza. Negative 3.2 divided by negative 1.6. I assume, I mean, I assure you, no one's dying down there. No one's dying. Everything's fine. This happens all the time. Everything's fine. Okay, this is the x coordinate when the ball achieves its maximum height. So when you're being asked how far is the ball when it reaches the max height, well, that's what this quantity represents. The x value is here your distance away from the origin. So we can say already, without even saying anything about the max height, that this answer is 2 feet. So it's a 2-foot horizontal distance at the max height. So this is the x coordinate of your vertex. Any questions there? Okay, now let's find the y coordinate of the vertex. Now remember, to find the y coordinate of the vertex, you are looking for f of negative b over 2a. But in this case, our function is not called f, it's called h. So we're going to use h. So we're going to take our function and we're going to evaluate it at 2 because that was the x coordinate of the vertex. Okay, so we're looking for h of 2, which is negative 0.8 times 2 squared plus 3.2 times 2 plus 6. And that you can put right into your calculator. So negative 0.8 times 2 squared plus 3.2 times 2 plus 6. And you should come up with 9.2 feet. This is your max height. And this was for part A. Any questions on part A? Okay. Part B, how far does the ball travel horizontally before hitting the ground? Well, remember what your graph looked like. Kind of looked something like this. This was your max height. This is where the ball hits the ground. So remember, h of x, the graph's y value, is telling you how high the ball is at a given time. So the ball is 6 feet here. It goes up and up and up and it reaches its max height. Then it goes down again. Now the height is 0 at this point. So the height equals 0. What we're trying to do is figure out horizontally what this point represents. So what we're trying to find are the solutions to the equation. So we are trying to find h of x equals 0. Okay. Excuse me. Screaming like loud and clear up here. Yeah. The third kid is always the craziest kid. She's like trying to climb on a glass table, apparently. Okay. So this is what we're trying to find. We're trying to find when h of x, your function, is equal to 0. Now, when you solve for this, remember this is a quadratic function. You're going to find two values here. The other value is going to be over here. We don't care about this value because remember that the ball was thrown here. That's your starting point. It was thrown from a height of 6 feet. It's not getting thrown back the opposite direction to give you negative feet. That's not happening. I know you physics people are like, well, of course you can have negative feet. That's fine. You're going in the opposite direction. That's not what we're doing here. We're trying to find this value. So we're going to set our value of h of x equal, or our function h of x equal to 0. So let's see, our function is negative 0.8x squared plus 3.2x plus 6, and we're going to set it equal to 0. And then we'll solve. Now, it's up to you how you want to solve this. You're going to have to use the quadratic formula. However, you might want to get rid of these decimals first. If you want to do that, that's fine. If the decimals don't bother you, keep them in there. The last thing I want you to do is try to manipulate it and accidentally manipulate it wrong, and then your value for x is wrong. But let's go ahead and solve. X equals, and I'm going to remind you of the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so let's go ahead and plug in these values here. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And then simplify. Negative 3.2 plus or minus the square root of 3.2 squared is 10.24. And if you want to do this all at once in your calculator, that's fine, but there is a lot going on, so you might want to split it up. 4 times 0.8 times 6 is 19.2. Be careful here with your negative signs. You have two of them. Two negatives make a positive. So we're going to add 4 times 0.8 times 6, and you get plus 19.2 divided by negative 1.6. And continue to simplify. So 10.24 plus 19.2. These are already truncated. These are not truncated decimals. These are exact. They're terminating. So you don't have to worry about getting weird values here. 29.44 divided by negative 1.6. Okay, now normally when you're doing a problem like this, you pick the plus value. However, in this case, because you're starting out with a negative and dividing by a negative divided by a negative is a positive. Now, if you're not sure and you originally go for the plus value, that's fine, but you're going to find that your final answer is negative and you're actually going to get this value, not that one. And if you're not sure what I mean, well, we'll do both of them. The first one is x equals negative 3.2 plus the square root of 29.44 divided by negative 1.6. Don't cancel out the negatives, by the way, because you cannot cancel them out. You would have to cancel out a negative 1 out of every single term. You don't have that. So if you did this, negative 3.2 plus the square root of 29.44, enter, divided by negative 1.6 equals approximately negative 1.39. You don't want that because you don't want a negative value of x. Your x is going forward in time, not what's happening before you threw the ball. You're not going backwards. So that value of x is this value, the first one. You don't want that. Find the other value. In that case, we're going to use the minus sign. And you'll do this again. So negative 3.2 minus square root of 29.44 divided by negative 1.6. And you get approximately 5.39. On your sheet, I wrote 5.4. And that's the number of feet after which your ball hits the ground. I do want to remind you of how to do this in your calculators. And you know what? I'm going to pull up your emulator here because I don't want to be holding this thing sideways. Before I do this in the calculator, does anybody have a question on the work? Or why we did this? What it means? Okay. All right. Let me share my calculator here with you. Ooh. Easier than you thought. That's good. All right. Wonderful. Clearly the last time we did this was matrices. Okay, let's graph the function. The function I'm talking about is your h of x function. So we're going to go with negative 0.8 x squared plus 3.2x plus 6. And then we'll graph it. And there it is. It's wonderful. It doesn't need to be zoomed in any further. But what I'm going to do now is show you how to work on point A and B in your calculator. So I don't want to spend too long on it, but I do want to remind you of how to do this. So for part A, we found the vertex. So if you find the vertex and you're kind of like, I'm not sure, does this make sense? Whether or not it's going to make sense, you could probably eyeball your calculator to see. Usually you're not going to make an error that's going to get you close, but not correct. Usually if you make an error, you're going to get a vertex that's way off. But let's talk about how to find the value for the vertex. So go to your second calculate menu. So it's actually second trace to get to the calculate menu. And we're going to find the maximum value. So remember we were talking about the maximum height of the ball and the value of x at which the max occurred. That's what we'll talk about. So we're going to hit number 4 for the maximum. And what you're going to do is you're going to approach the max, but stay on the left, because notice it says left bound. We're trying to just stay on the left-hand side of that vertex. And I don't even know if you have to get that close or not, but you have to be somewhere over there on the left. So see how my cursor is like on the left-hand side of that vertex. I'm going to hit enter. Then it's going to ask me for a right bound, and I'm going to move the cursor to the right of the vertex, just somewhere where you can clearly see it's to the right. And then we'll hit enter again. And then it's going to ask if you want it to guess, and you're going to let it because it's a very good guesser. Now, the maximum it's giving you is that x equals 1.999999997. Don't worry about that. Usually your calculator sometimes can struggle to get the correct number of digits. If you have a CE, it's possible that your calculator would not give you that 0.99. It might actually just say 2. Let me see, I'm doing that on mine right now. Nope, mine still says 1.9999999. It has no 7, but it's got 9s on it. If you see this, you can safely assume that it's 2. It's truncated some decimals and gotten as close as it possibly could. So your maximum occurs when x equals 2 and y, you can see here that y is 9.2. So 9.2 is the maximum height of the ball that we found in part A, and 2 was the horizontal distance the ball traveled when it hit that maximum height. Any questions on finding the maximum? The other thing that we found was we found the zero, or we found the value of x when the function was equal to 0. We're going to do that in the calculator too. So go back to your calculate menu, which is second trace. And this time I'm going to use number 2 for 0. I'm trying to find the 0 of this function where the function's value is 0. To do that, I'm going to get to the left of where I think the 0 is. Don't get too close, but clearly you're on the left-hand side of the x-axis there, and hit enter. And then move your cursor to where you're clearly on the right-hand side. Enter. And ask it to guess. And it has guessed 5.391165, which is, I think, exactly, yeah, I got 5.391164,992 when I put this in my calculator. So yeah, 5.39 is the value that your calculator came up with for finding that 0. I'm assuming that using your calculator to check your zeros will even be more beneficial than using it to check the vertex of your quadratic function. So use that as a check. You have to show me your work though. I mean, it's great that you know how to use your calculator, but you can't just say 5.39 feet. Or you can't just say h of x equals 0, 5.39. You got to show me your work. It's very important. Any questions about using your calculator to find the answers for parts A and B? To check your answers, I should say. Okay. Wonderful. Oh, what I like, I didn't realize that when you look at the key press history, it's next to these arrows where I scrolled over. It says 5 and 7. That's how many times I clicked. Interesting. Or 13 and 2. Interesting. It's kind of cool. All right. Other questions from your review sheet? Let's see. If you don't have anything, I'll look and see what I think you'd struggle with. You guys did pretty well with the interest problems, the compounding. Let's see. What about all these equations of lines, 1 through 3? I know it's basic, but I mean, it's been a long time. Did anyone want to go over any of those with slopes and parallel and perpendicular? Sure. Okay. Let's do number 3, just because, well, actually, that doesn't talk about parallel perpendicular. Let's talk about slope. Okay, we'll do 1 and we'll do 3. These will be pretty quick. Okay, so number 1. You're being asked to find the equation of a line in point slope form, which is perpendicular to 2x plus 3y equals 4, containing the point -1, 3 in point slope form. Okay, so you're being given the equation of a line, and then you're being asked to find a line that's perpendicular to this line going through this point. So what you need to write the equation for any line is a point and a slope. Well, you have a point and you do have a slope. You just have to find it. It's in here. In order to find the slope, you're going to have to rewrite this equation in slope-intercept form. So get y by itself by subtracting 2x on both sides of the equation. And then divide each term by 3. So the given line actually has a slope of -2/3. But your line is perpendicular to this line. A line that's perpendicular is going to have a slope that is opposite reciprocal. So perpendicular slope is opposite reciprocal. So that means you're going to take the opposite sign. So if it's negative, make yours positive. If it's positive, make yours negative. And then you're going to take the reciprocal, which means invert the fraction. So your perpendicular slope is positive. I'm so used to going plus minus. Positive 3/2. Okay, so change the sign and then switch the numerator and denominator. And remember, the only two things you need to write the equation for a line are a point and a slope. Well, now you have the slope. So use your slope with the given point to write the equation of your line. Point slope form is y minus y1 equals m times x minus x sub 1. Oh, I wrote y minus 1. Yikes, y minus y sub 1 equals m times x minus x sub 1. So you're going to substitute the coordinates of your point and use the perpendicular slope. So the point you were given was -1, 3. So -1 was the x value, 3 was the y value. So -1, 3. Use this for x sub 1, y sub 1. So y minus 3 equals positive 3/2 times x minus -1. And if you want to go right to x plus 1, that's fine. And then you're going to simplify. I mean, I probably wouldn't ask you to leave something in point and slope form. I normally like things written in slope intercept form, but this is technically your point slope form. Most of the time I ask for slope intercept form. So if I did that, you would distribute and then add 3 on both sides. So you would say, okay, y minus 3 is 3/2 x plus 3/2. So distribute that 3/2 into the parentheses and then add 3 on both sides. So you would have y equals 3/2 x. So 1.5 plus 3 is 4.5, which is 9/2, or you can think of 3 as being 6/2. 6 plus 3 is 9. Whoops, sorry. This is slope intercept form. So usually you'll start with point slope form and then you'll move into slope intercept form. Some of you guys learn to do this by plugging in the slope and the coordinates and solving for b using y equals mx plus b. That's totally fine. Some students really like that. That's up to you. So that was 1. Any questions on 1? Okay, so 3, I just wanted to show you a similar example when you're not given a slope, but you're just given 2 points. So you're given the 2 points, 3, -4, and 2, 1. Now, you're being asked to write this in general form. I would still probably have you write this in slope intercept form. But anyway, if you're given 2 points, you need to find the slope. The equation for slope is m equals y sub 2 minus y sub 1. So the change in y over the change in x. Make sure that your subscripts line up properly. Like, don't write y2 minus y1 over x1 minus x2. Don't do that. Okay, and then sub in your points. You decide which one's which. I'm going to make the first point, point 1. And I'm going to make the second point 0.2. Okay, so this will be 1 and 2. And then you'll just pop it into your formula and find the slope. So y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And you'll get 5 over negative 1, which is negative 5, which is your slope. And once you find your slope, use point slope form to find the equation of the line. Remember that in order to write the equation of the line, you need two things, a point and a slope. You have a slope, you have 2 points. Pick a point. So I'm gonna just pick one. So I'm gonna use the one with only positive coordinates because it'll make my life easier. Use this point and your slope to write a line. So y minus y sub 1 equals m times x minus x sub 1. And then you'll simplify. So this is point slope form. To get to slope intercept, you're going to distribute and you're going to add 1 to both sides. And this is your slope intercept form. And don't worry about general form. I put it on the sheet. It's basically just got 0 on the right-hand side. It's a weird form. Okay, so those were the line things from chapter 2. Circles, midpoints, distance, that was all recent. Does anyone want to talk about number 7 with the rational function and the graph and the asymptotes, the domain? Review symmetry. Number 12, we kind of already talked about finding vertex and intercepts when we did number 52, whatever it was. 18, let's see, what's 18? Find a polynomial of degree 4 with lead coefficient of 1 and with the given zeros. Okay, so number 18. So the zeros that you're given are 1, negative 2, and 3 plus I. Remember that when you're given one complex zero, you can use the complex conjugates theorem to get the other one. Remember, you're never just going to have one imaginary zero. You're going to always have 2 of them. They always come in pairs. So you'll always have A plus BI and A minus BI. In this case, B is just 1, A is 3. So if you're given 3 plus I, the other 0 is going to be 3 minus I. This would be the complex conjugate. Okay, so always start out doing that, making sure that you have an even number of imaginary zeros. So you actually have 4 zeros for this function. You're being asked to write the function that has these zeros. You're being given the information that the lead coefficient is 1. Because you have lead coefficient 1, so normally, remember when we were doing this, we would start out by saying f of x equals a sub n times blah, 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 blah. We don't have to do that in this case because you're being told that the lead coefficient is 0. Or I'm sorry, not 0, 1. Lead coefficient is 1. So this is not needed. I mean, you can always write it as 1, but why bother carrying it around? That means that you can just go along your merry way building your function. So what you're going to do is start out with f of x, and then you're going to just build this backwards. So instead of, if you have a 0 of 1, it had to have come from the factor x minus 1. Because remember, if you were to set this equal to 0, well, you'd say x minus 1 equals 0 and x equals 1. So your factor is always going to use the opposite value. Your factor is always x minus c, and your zeros are always c. So for -2, you'll have x minus -2, which is actually x plus 2. And then for your complex zeros, you'll have x minus, be careful with your parentheses here, 3 plus I, and x minus 3 minus I. And then we'll just go through and complete the simplification. If you want to go ahead and multiply in the first factors first, I mean, that's fine. There's a lot going on here, so you decide. So you'll have x squared plus x minus 2. Now simplify what's behind here. You'll have x minus 3 minus I and x minus 3 plus I. So distribute this negative sign into your parentheses. Questions so far? Okay. If I were you, I would not multiply into these imaginary factors. Simplify these first. Remember, these are complex conjugates. Because of that, we're going to get these i's to cancel out. So you can hold on to this trinomial and simplify what's behind it. Just, be careful. You're going to have to do a lot of these little computations here where a lot of things can go wrong. I'm going to start by multiplying x into all 3 of the terms in the last factor. Then I'm going to multiply -3 into all 3 terms in the last factor. And then I'm going to do the same with -I. So x times x is x squared, x times -3 is -3x, and x times I is ix. Now I'm going to use the -3. So I'll have -3x. -3 times -3 is +9, and then -3i. And one more time using the -I, I'll have -ix plus 3i minus I squared. And simplify whatever you can. These I terms should cancel. If they don't, you've done something wrong. So the ix and the -ix are gone. And the 3i and the -3i, gone. And remember, I squared, well, if I is the square root of -1, I squared is -1. So when you see these I squared terms, you can just switch the sign on them. So instead of being minus I squared, this turns into +1 because it's minus -1, which is +1. Okay, so let's simplify what's left. You still have this trinomial in front. Then you have x squared. Combine your x's to get -6x. And then what you're left with is 9 plus 1, which is 10. And then you're going to have to go through and multiply these trinomials together. Any questions here? Okay. So I'm going to start out with x squared. I'm going to multiply into all 3 terms. Then I'm going to move on with the x, all 3 terms, and the -2, all 3 terms. Usually when I do this, I do it in 3 different rows just to line everything up nicely. But you don't have to. X squared times x squared is x to the 4th. Then you'll have -6x cubed and plus 10x squared. Now you'll move to the x. X times x squared is x cubed. Then you'll have -6x squared plus 10x. Notice how I just like to do this where I line up all my like terms. Negative 2x squared plus 12x minus 20. And then I'm going to add them vertically. So we have negative 20 as our constant, plus 22x as the linear term. 10 minus 8 is 2x squared. It's positive. Negative 6 plus 1 is negative 5. And x to the fourth. So minus 5x cubed plus 2x squared plus 22x minus 20. And if you'll remember what we were actually trying to do, we were trying to simplify this to find f of x. Well, we multiplied through, and now we can say that our function looks like this. And remember, because we were told the lead coefficient was 1, we didn't have to go backwards and solve. So if you were told something like f of 3 is 2, then that's where you'd have to go back in, evaluate the function at 3, set it equal to 2, and solve for a sub n. Any questions on 18? I don't remember if the one on your test, I think I did have you go back and solve. I don't remember though. I'm pretty sure I said something like f of 0 is 1 or something, and you had to go back and solve. Okay, technically class is over. I'm going to be in my office hour for another 15 minutes, so it's up to you if you want to stay. Feel free to email me if you have questions before Wednesday's final exam. Stick around if you want to go over a couple more problems from the review sheet, but if you find that later on you're going through the review sheet and something's not clear, just send me an email on blah, blah, blah. How did you get this or that or something? Just let me know. Otherwise, I'll see you on Wednesday at 6. So if you want to drop off the call, that's fine. If you want to stick around for the office hour, then let me know what else you want to go over. Does anyone want to go over 17? You're welcome, Michael. You're welcome, Beth. It's been a pleasure. Stephanie. Can you hear me, Stephanie? Oh, not that Stephanie. Other Stephanie. Sorry. Stephanie Fu. Thank you, other Stephanie, though. Okay. Stephanie Fu. Okay. You're going to love me and hate me all at once. You have the highest score in the class, and it's an A. So I'm exempting you from the final. So I totally forgot that I was going to do that. And then when I just noticed your name again, I remembered like, oh gosh, I totally should do that. Yeah, so sorry, you just sat through this whole thing, but at least you're done. So you don't have to take the final. Sorry, you love me and hate me all at once because you just sat through this whole thing. Sorry. Sorry, it's such a weird semester. I forgot that I usually do that. And I think I mentioned it at the beginning of class. The person with the highest score, as long as it's an A, gets exempted, and that's you. So don't worry about it. It's been recorded. So if you need proof, I know everyone's always like, are you sure this doesn't seem right? You can always send me an email and I'll send you along a verification, but I'll enter your grade as an A. Don't worry about it. Everything's fine. You don't have to take the final. Okay. That is all. Okay. Did anyone else have questions? Sebastian or Rommel? You're welcome. Sorry, I wish I would have thought about it earlier. I would have emailed you. No. Okay. Well, let me know if you have questions. I'll be sitting here if you think of anything. Yeah, you gotta try your best. That's all you can do. Do the best you can. It's such a weird semester. I feel terrible for you guys. I hate teaching like this. It's rough, so I can't imagine trying to learn like this. It doesn't work for everyone. Yeah, I know. Especially with online tutoring. So normally if my students have trouble, they go to the tutoring center. Can't do that anymore. I understand. Yeah, I mean, this is all for tonight, unless you have questions or wanted me to go over anything in the office hour. I have 11 minutes if there was something that you wanted to go over, but otherwise that's it. You too. Have a good night. See you Wednesday.